Take 2 of 5-5 absolute value inequalities. I have no idea why I recorded the video and got halfway through just for it to delete itself. So, a reminder, absolute value, again, measures distance from 0. So we talked about absolute value equations back in chapter 2. So again, if I have absolute value of x equal to 5, I'm asking where is the distance from 0 equal to 5? And well, there are two spots where that happens. One of them, of course, is at 5, which is 5 away from 0. And the other spot that is 5 away from 0 is -5. So the two answers to this are 5 and -5. You might also recall that if we had maybe like a slightly more complex equation, say absolute value of 2x plus 1 equals 7, the way that we would solve this is we'd say, hey, well, I want my distance from 0 to be equal to 7, so I need to figure out where 2x plus 1 is going to be equal to 7. But then the 2x plus 1 could also be equal to -7, because again, there are two spots where that distance from 0 equals 7. One of them is at 7 and the other is at -7. So we would split and solve this into we'd split it into two equations, solve both of them, and we'd get two answers. Well, we're doing a similar thing with inequalities today. So we are going to do absolute value inequalities. Again, the process is essentially the same as equations, or at least the solving steps. The graphing is going to look a little different. So these are kind of our steps for today. Step 1 is we're going to get the absolute value by itself. This is pretty much always done for you. You shouldn't usually have to do this, but again, you would want to make sure the absolute value doesn't have anything by it. Then you're going to determine if it's an and or an or problem. We'll get to that in a minute. And you're going to check to see if the problem is all real numbers or no solution. That's what we'll talk about tomorrow when I come back. The third thing we're going to do is, again, we're going to split into the two problems like I just showed you with the absolute value equations. We're going to have one regular problem and one negative problem. However, again, if you remember from like kind of the theme of the chapter is when we start throwing those negatives into absolute value, when we throw those negatives into inequalities, they don't work out anymore. So to account for the fact that we're just throwing a negative in there, we need to flip the sign to go the other way. Okay, then we solve the two mini problems and we graph. So absolute value greater than a positive number, you're going to treat that as an or problem. Absolute value less than or equal to a positive number, you're going to treat that as an and problem. You might be wondering why I'm specifying that this is a positive number. If you remember from solving absolute value equations, when you have absolute value equal to a negative, that's not really possible because absolute value is always positive. So we have a similar kind of situation happening with absolute value that we'll talk about on Friday. Let's explain this real quick. Why absolute value greater than or equal to a positive number is an or problem, okay? So if we just think about a really simple example real quick, if I have absolute value of x greater than or equal to, say, 2, what I'm asking is where is the distance from 0, that's absolute value, where's that distance from 0 greater than 2, right? Well, first off, there's two spots where that distance is equal to 2. One of them's at 2, the other's at -2. But again, I'm saying I want that distance to be greater than 2. I want to be further than 2 away from 0. So that would be numbers like 3 and 4. So I would shade this. And over here, that'd be numbers like -3 and -4. So that would be these numbers down here. And if you look at this graph, this is an OR graph, right? I have greater than or equal to 2 or less than or equal to -2. Likewise, we have the opposite when you have absolute value less than a positive number or less than or equal to a positive number. This ends up being an and problem. Again, if I make a really simple example real quick, absolute value, say, less than 1. Again, well, there's two spots where absolute value equals 1. One of them's at 1, one of them's at -1. But I want my distance from 0 to not be further than 1. I want it to be less than 1. So I don't want to get further than 1 away from 0. So that would be all the numbers between 0 and 1. And in the other direction, that'd be all the numbers between 0 and -1. And of course, if you look at that picture, that looks an awfully lot like an AND graph because we're shading the middle. So absolute value less than or equal to positive number, and problem, greater than or equal to, or problem. So I'm going to run through 2 examples of each kind of quick, and then I'll be done. So absolute value 2k plus 1 greater than 7. So this is an OR problem because, again, our absolute value is greater than a positive number. So the way we solve this, again, similar to when we did this with equations, we're going to split it into 2 problems. One of those problems is basically identical. 2k plus 1 greater than 7, nothing really changes. That other problem, I need to take into account what if the distance from 0, which needs to be 7, is in the other direction at -7. So I'm going to make this inequality with a -7 in it, but since I switched this to be a -7, now the inequality is not going to hold, so I need to flip the inequality to go the other way. Okay. From here, I'll solve pretty normal. 2k greater than 6. Here I have 2k less than -8. So I'll divide by 2. Here I get k less than -4. Here I get k greater than 3. Again, I should have wrote this at the beginning. We have absolute value greater than 7. So this is an OR problem. So I'm going to put the word OR in between my answers, and I'm going to graph this like an OR problem. So number line. On the left, I'm going to put the smaller number. On the right, I'm going to put the bigger number. And then again, I want k greater than 3, open circle on 3, shaded to the right. K less than -4, open circle, shaded to the left. Okay. Let's take a look at an AND problem. Here's a very basic AND problem. I know this is an AND problem because my absolute value less than a positive number. Okay, so really that's only going to change the graph. The solving process is still the same between the 2 of them. So I'm going to split into 2 problems. One problem is identical. The other problem, again, 2 things I need to change. One thing I need to change is the direction of my sign. The other thing is I need that negative number. So I'm going to go ahead and solve this. Add 5, add 5. Here I have a is less than 8. Over here, I get a is greater than 2. Again, this was an AND inequality, so I'm going to shade it like an AND graph. So open circle on 8, open circle on 2, less than 8 is shading to the left, greater than 2 is shading to the right, but of course this is an AND problem, so I only keep the overlap. All right, one more example of each. I'm going kind of quick. Okay, so again, this would be another AND problem because I have my absolute value less than or equal to a positive number. So again, 2 things I'm going to do. I'm going to write one of the problems identical to what I have above. And then in the second problem, again, 2 things I need to switch. First, I need to switch the direction of the sign, and I need to make the number negative. And I should put the word "and" between them. Okay, from here, I'm solving. Add 2. I have 5t greater than or equal to -4. Over here, I have 5t less than or equal to 8. Divide by 5. Wish I had better handwriting. Over here, I have t is less than or equal to 8 divided by 5 is 1.6. Over here, I have t greater than or equal to -4 divided by 5 is -0.8. Again, this is an AND problem. I'll put them both on my graph real quick. Reminder, with a decimal, we can just go to the next nearest whole number. So I'm going to put 1.6, put 2. These are both closed circles. This one here is less than or equal to, so it's shaded to the left. This one's greater than or equal to, so it's shaded to the right. Again, this is an and problem, so I'm going to keep the middle and erase the extra. All right, one more look at an or problem. And it's been a while, I think, since we've talked about one like this where you kind of have the mega fraction. But again, this would be an or problem because I have my absolute value greater than or equal to 1. So again, I'm looking for spots that are going to be more than 1 away from 0. So that's going to be moving away from that number in both directions. So again, split it into two problems. The first problem is the same. The second problem, there's two things to do. Thing number one is I need to flip the inequality. Thing number two, again, is I need to make that number negative. From here, solving, a reminder that when you have one of these kind of like mega fractions where the whole thing is divided, it's best to get rid of that first. So I'm going to start by doing the times 4. That'll cancel my divide by 4. I have x plus 2 less than or equal to negative 4. Over here, I have x plus 2 greater than or equal to 4. Last step is I'm going to minus 2 in all of these. And I have x less than or equal to negative 6. Over here, I have x greater than or equal to 2. Again, this was an or problem, so I'm going to shade it as such. Negative 6, negative 7. Ban any of them that did the 6, 7. Close circle on the 2, shaded to the right. Close circle on the negative 6, shaded to the left. So that's absolute value inequalities. Again, kind of the big takeaways. If it's greater than a positive number, you got an or problem, treat it like an or problem. If you have it less than a positive number, and problem, treat it like an and problem. Okay. Again, you're going to split into your two subproblems. You're going to have one that's positive. That's kind of like the normal one, right, where you don't change anything. And then in that other one where you make the number negative, to account for that, you need to flip the inequality. So two things to remember there. All right. Good luck. Assignment is posted in Schoology and the notes.